everyone. Here we are going to discuss about the anti-Markonikov's addition in alkenes. Now let's do the example. CH3CH double bond CH2. If we add HBr, this is an unsymmetrical alkene. This is an unsymmetrical reagent. When we add the two, then the product obtained will be CH3 CHBr CH3. This is 2-bromopropane. But here which rule is followed? It is Markonikov's addition happened. Markonikov's addition happened. But what if the addition is taking place in presence of peroxide? We will take the same reagent, we will take the same molecule, but one additional thing is there that we will be doing the addition of HBr in presence of peroxide. So let's see how is it. Like say for example, if it is CH3CH double bond CH2 and this is HBr, the addition is taking place in presence of benzoyl peroxide. Now in presence of benzoyl peroxide, there will be a change. We can well observe it that in place of getting 2-bromopropane as the major product, we get 1-bromopropane as the major product. So Br will be going to the other carbon and the product obtained will be this. It will be 1-bromopropane. 1-bromopropane is the major product obtained. So here we should observe that without this peroxide, we were getting this as a major product. Without the presence of peroxide, we were getting this as a major product. But the moment the peroxide is present, this is reversed. That is why this type of addition or this particular reaction we name as anti-Markonikov's addition. Why? Because the addition is taking place against to the Markonikov's rule. Right? Now the second name is that is peroxide effect. We call it as peroxide effect also. Why? Because this effect is happened, or you can say this anti-Markonikov's addition is taking place in presence of peroxide. This is also called as Kharash effect because it was observed by MS Kharash and FR Mayo first. That is why we name it as Kharash effect also. Now there is a mechanism to understand why in presence of peroxide the addition is reversed, or you can say Markonikov's rule is not followed in presence of peroxide. So let's start with the mechanism. Mechanism of anti-Markonikov's addition or mechanism of anti-Markonikov's addition or peroxide effect. Mechanism of anti-Markonikov's addition. Now how is it? The first step here is that is homolytic cleavage. What is the homolytic cleavage of whom? Homolytic cleavage of the peroxide. Benzoyl peroxide we have taken as a catalyst. So this is the first step. Here we have C6H5 C double bond O. This is benzoyl peroxide. Benzoyl, this is benzoyl group. C6H5CO is the benzoyl group. Then there is another benzoyl also, C6H5 C double bond O. This is another benzoyl. Peroxide, that is why two oxygens are there in between. Now the homolytic cleavage of the bond will take place. So this oxygen-oxygen bond will undergo homolytic cleavage. So the pair of electron will be like this. It will be undergoing the homolytic cleavage like this. So the product obtained will be C6H5 C double bond O, single bond O, 2 to 4 and 1 odd electron. So both the species will be same. This will be the free radical obtained. Now here this oxygen is more electronegative. That is why it will with an odd electron is going to be unstable. It tends to pair up its electron by withdrawing the electron from this carbon-carbon bond. So carbon-carbon bond of this carbon and the phenyl carbon will undergo homolytic cleavage again. So the odd electron present on this carbon will pair up this oxygen's electron, and that's how it will be forming carbon dioxide. It will form carbon dioxide. It will pair up the electron present on this oxygen, and that is how it will be forming carbon dioxide. Now what about this? This will be left with 2 odd electron like this. 2 phenyl free radicals are formed. C6H5 with an odd electron, another C6H5 with an odd electron. So the phenyl free radical will be formed. So this is the first step, homolytic cleavage of peroxide. Now the second step is that after this homolytic cleavage of benzoyl peroxide, phenyl free radical is obtained. Now this phenyl free radical will be causing the homolytic cleavage of Hbr. How is it? It will cause the homolytic cleavage of Hbr. So the odd electron of hydrogen will be pairing up this electron. So that is how it will be converted to C6H6 and we will be left with bromide free radical. So this is the second step. Now coming to the third step. Now what is the third step? Third step is this bromide free radical will cause the homolytic cleavage of the pi bond present in alkene. So the next step is homolytic cleavage of pi bond. How is it taking place? It is CH3, CH, double bond CH2. Now this bromide free radical will be causing the homolytic cleavage of this pi bond. So if it is undergoing homolytic cleavage, what are the species we may obtain? We will be obtaining CH3CH with an odd electron. It will be a single bond now. CH2 with an odd electron. It will be like this because the pi bond is undergoing homolytic cleavage. Sigma bond is still retained. Now this bromide free radical can pair up this electron or this bromide free radical can pair up this electron. Say if we talk about, say this is the number 1 route. If we talk about pairing up of this electron, what we will get? Now say for example, it may pair up any of the 2 electrons. So if it pair up the number 1 electron, how the product will be? The product will be CH3CH, CH2Br. And say it follows the second route. Second route means it follows this second, pair up the second electron. Then how is it going to be? It will be CH3CHBr and this carbon is with an odd electron. So we are getting 2 intermediates here. This is secondary free radical and this is primary free radical. We know it very well, secondary free radical is more stable. So that is why it will be forming the major product, while primary free radical is less stable, more stable. This is more stable, sorry. This is more stable. So that is why it will be leading to the formation of the major product. Now what is the next step? Next step is again homolysis of Hbr. So homolysis of Hbr will take place once more. Homolysis of Hbr is the last step. So what will happen? This CH3, because this free radical, this intermediate is more stable, so that is why it will be forming the major product. So CH3CH, CH2Br, it will cause the homolytic cleavage of Hbr. So we will be getting H ion and H free radical and bromide free radical, and this H free radical will be pairing up this electron, and that is how we will get CH3CH2, CH2Br as the major product. 1-bromopropane is the major product. Similarly, the other free radical will also be paired up, but that won't be forming the major product, that will be just the minor product. This is the free radical Hbr, and that's how it will be forming CH3, CHBr, CH3. So this will be the minor product in presence of peroxide. Thank you.